The use of a projection system, I still see this as a very important thing to have, because when you work in an environment where you have to assimilate a multitude of field surveys into one sort of fabric, we've found that it works best on a local type projection where everything appears to fit pretty darn well together with intolerances. Once in that framework, I could see the thing being moved to some sort of a XYZ storage space for universality purposes, but I can't see getting away from a projectioning system when you're working with field data. When field data is brought in by surveyors using a variety of devices. So I'd like to see this geodetic data model actually incorporate a good projectioning system that can move you from like a local plane to a state plane system, for instance, if the state requires that storage mechanism. Your comments on that, Mr. Van Sickle?
I agree with you entirely, and I think there's a misunderstanding. I am not suggesting, and I tried to say this, I'm not suggesting that projected coordinates are going to vanish. I am not suggesting that projected coordinates are going to vanish. What I'm suggesting is this: storing an XYZ in time. And what I mean is, the legacy data is huge. The legacy data sets are not going to get thrown away. There's no reason to act that way. However, there's no reason at all that they can't be stored in XYZ in time. They can certainly be stored that way, in addition with the plane coordinates. Okay, the question's obvious. Why? And you said it, I agree with you. Universality. If you do it that way, then when you transform into any system, it doesn't matter what it is, you're coming from a common base. Now, I understand that the minute that you say that, the obvious thing that comes up is, all right, something may be in a state plane or a UTM system or some other system. How in the world do you know what the XYZ coordinate is of that? Well, of course, there's error. There's problems. You don't know exactly. It's like, how do you transform from NAD 27 to NAD 83? Well, you've got algorithms that do it, but that doesn't take into account the errors that were inherent in the positions to start with. I understand that, and I agree with that. So, Michael, I am not saying they're magical. What I'm saying is this. It is my honest opinion, and I'll defend this strongly. Satellites are going to be the way we position from now for a very long time. Not forever, but for a very long time. These satellites use XYZ, Earth-centered, Earth-fixed, as their fundamental coordinate system, and in my opinion, it has always been silly to take those coordinates and project them in latitude, longitude, or a plane coordinate system, or into some system that wasn't native to them to start with. Okay. Obviously, somebody can say, fine. But what about the stuff that happened before that? I'm saying start in XYZ too, so we can start the transition to the time when the plane systems are not going to be required. There's plenty to say on the subject. I'll try to shut up.
There's a question back here before we carry on.
I'll try to get this as succinct as possible. There's many legal areas that I think we have to deal with. Just a few of them, height certifications needing to be in orthometric height. Land boundary surveys needing to be at the surface of the earth. AASHTO standards for highway construction having certain radius and geometric relations in engineering design. And kind of on that last topic, when something I've noticed when I'm dealing with various projections and having one set of data going from one design framework in one projection, deprojecting and reprojecting rigorously to another projection, you have this loss of fidelity, as it were, of the original data itself. And what I mean by that is, if, you know, as an extreme, if I had a a horizontal curve in state plane coordinates, and I have a relationship between a PT, a PC, and a radius point, when I deproject those and reproject those into something else, those radial lines are no longer the same length. I no longer have a circular curve. I have some other shape. So when we get into, I completely agree. I think, Earl Burkholder in his 3D global spatial data model book, he's talking about getting into the ECF environment for archiving the actual positions of this data. There's still going to be a complexity. Yes, there's universality, but there's loss of fidelity. Whether it be, original data was in the orthometric height system, and now it's, you have some form of loss of fidelity because what geoid model did they use, or what, field technique did they have? My question, in summary, would be this to the panel: what are your thoughts about, potential losses of fidelity of original data being centralized back into one common reference frame for archiving purposes?
Does anybody want? Well, one of the things that I'm thinking is I don't believe, and I don't think that Jan is saying that we will no longer ever need to project, and projection should just simply disappear or go away. But fundamentally, all surveying, nobody surveys an XY coordinate. Nobody even surveys a latitude and longitude, except years ago when we did some astronomical observations. Nobody surveys in the systems that we project into. The fundamental, and this is kind of addressed to Michael too, the fundamental information that comes to us is X, Y, Z from the satellites. Apart from the Keplerian coordinates, I mean, you could say, no it isn't, it's something else. But X, Y, Z is essentially what we get from our current methods of surveying, apart from or doing geodesy, I should say. And I do want to make a little bit of distinction between the geodesy and the surveying. Doing a land boundary survey and having a geodesy data model, these are different. And this is still being worked out too. I'm not making a survey model. I'm not making a survey data model. I'm trying to build a geodesy data model. And so this is why there's a mix here, I think, of thoughts that are coming through. This isn't something that is going to support surveyors primarily, but geodesists primarily. So there's a difference in the philosophy of how I'm building them. And so I don't know if that's really answered the question, but it's maybe shed more light on where I'm going and where I'm not going with this in mind. Does that help? Probably not. But I don't think I answered your question. Maybe somebody else can.
I think it's an excellent concept for where we could go from now. We are at a time in which we can collect this kind of data. Just to briefly address some of the issues with legacy data. And I'm in agreement with Jan. I'm a great fan of XYZ coordinates. But taking virtually any classical, historical, particularly horizontal reference frame anywhere in the world, it's virtually impossible to come up with good XYZ coordinates simply because there were never any ellipsoid heights generated for the 200 plus or more horizontal datums. And regrettably, the overwhelming majority of those datums, and I'm sure many people in here have had experiences working outside of the more developed countries. You go into undeveloped countries and try to find their legacy data, their real data, their observations, much like you go into the NGS database, you can get real observations. Regrettably, there are very, very few institutions in the world that capture that kind of information so that at NGS, we can generate reference frames based on original observations. This model, however, would provide that sort of platform where developing communities would have that capacity that they lack today. And hopefully, it would help us develop better, particularly in the realm of horizontal datum transformations, develop way better models than much of the, well, I won't say what I think about them, many of the transformations that are available to us today, primarily from our colleagues at the U.S. Defense Department. They are what they are, and regrettably,